Hey guys, so today we don't have the whiteboard, but I'm going to be teaching you guys how to balance chemical equations. Alright, so let's start off with this. So we have two hydrogens, two oxygens, and then that gives us H2O, which is water. So now that we have both our H and O, let's go ahead and see. So now we have two hydrogens on this side, so to help you out with that, we're going to go ahead and put a 2. And then after that, we have two oxygens, so on the left side, we're going to go ahead and put 2 for the oxygen. So now on this side, what is the problem? Why is this not balanced? So we have two hydrogens, so okay, perfect. Hydrogens are balanced, yay. But notice we only have one oxygen. So how are we supposed to do that? We have to have both of the numbers equal each other on this side. So the only way that we must be able to do that is if we multiply this one by 2. So now, once multiplying this by 2, you're going to get 2, and then yay, this is balanced. But how do we incorporate that into our equation? Well, by getting this number right here, that is going to be what you're going to put in front, which perfectly works out. So now you're going to have 2 moles, just the amount that you have of this compound right here. So now we have our chemical equation like this. So first step, so why does oxygen have a 2? Oxygen is a diatomic element. So just to know that, an acronym to remember your diatomic elements would be Birkeloff. I find it to be quite funny. It's a good acronym. So I'll go ahead and show you guys. That's going to be bromine, iodine, chlorine, nitrogen, hydrogen, oxygen, and fluorine. So just remember you have 7 of these. And you can also draw 7 on your periodic table and then just circle hydrogen. It's very helpful. To show you guys what I mean, go ahead and start right here at the nitrogen. So you go like this, and then down until you reach iodine. So to get you those 6, and then after that, hydrogen. Anyway, so that is our reasoning behind why we have an O2 right here. But now let's balance this equation. All right, so we're gonna go ahead and use our exact same method. So let's go ahead and just do it right over here. Okay, so now we have Al, aluminum. All right, so on this right side, we have 1. On this left side, we have 2. Okay, so we already know what we need to do at first. But let's label everything first. Okay, so now we also have our oxygen. So we have 2 on this side and 3 on this side. Okay, this is weird here because we can't just multiply 2 to get to 3. So we have to multiply this to the nearest even number. All right, so let's go ahead and do the harder one first. So we have the 3 and 2. We want to get this to 6. So we're going to go ahead and multiply this side by 3 to get to 6. And then we're going to multiply this side by 2 to get to 6. So we're multiplying 3 on this side for the O, so that's going to be our right side. Then we're going to go ahead and place 3 here, because that's what we're multiplying by in order to get 6 so that we can balance the oxygens. And then since we're multiplying by 2, we can go ahead and put our 2 in front of here. But you know what this 2 means? It means that both of these elements in here are getting multiplied by this. So by multiplying this and this, you're going to get 6 so that you can balance your oxygens. And then now we have to multiply the aluminum as well. So we also have to multiply this one by 2, which is going to get us to 4. So now if we have 4 aluminums and then 1 aluminum on this side, how are we supposed to balance this equation now? Well, we're going to have to multiply this one by 4. That's going to get us to 4, and that is going to balance our aluminums. So then you're going to go ahead and put a 4 right over here. Just remember that if you have a compound like this, if one of these elements are getting multiplied in the compound, you have to also multiply the other element in the compound by that same number, and then you can balance. So now let's say you got something like this. Wow, this is much more complex than what we were doing before. How are we supposed to balance this? And by the way, these symbols right here, these are just state symbols. So this AQ right here is just aqueous, which means this can be dissolved in water. This is solid, which means this is a solid. This is also a solid. And then this is gaseous. G is for gaseous. But we're not even going to worry about these state symbols right now. Right now, I'm teaching you guys how to balance equations. So let's do that. All right, so first let's go ahead and handle our hydrogen. So we're gonna multiply this by 3 to get to 6, and we're gonna multiply this by 2 to get to 6. Oh shoot, sorry. 6. So now we can go ahead and have our 2 here for the H3P. And then after that, we multiplied this on this side by 3. So we can go ahead and put our 3 in front of the H2. And now notice how this is an H3P. So like we discussed earlier, if this is going to get multiplied by 2, then this has to. And that just works out so perfectly because now our phosphorus they're balanced. So now that the rest of this is balanced, our final step is to deal with our magnesium. So in order to balance this, we need to multiply by 3, which since it's on the left side, that's going to go ahead and get us 3 MgS. And now we are balanced. So I hope this was helpful and thank you for watching. Bye.